Now we move on to our second type of plate boundary, convergent boundaries. So I would mention there are a couple of different strategies that I can think of regarding your text. One of them is to pre-read. So read your text before coming to the lecture. I say coming to the lecture because I'm thinking when we're not on virus lockdown and able to actually come to class. But I guess you can treat watching the videos the same way if you're watching the videos on these. So one strategy could be you read your text for that applicable section before dealing with the lecture videos. Or you could take a different strategy of watching the videos and then going to the text already having some idea of what it's talking about, and that might make it easier to digest sometimes depending on what your own preferences are. But I would note that both of those strategies do involve reading that text. So you should definitely be reading the text and not trying to get everything from just listening to the YouTube videos. That's not sufficient for a college level class, and you've got to dig a little deeper than that. It takes study on your part and particularly reading the material. I guess we really need this slide. I probably should have just taken it out and will for the third mechanism, but we're still trying to look at how the plate tectonics thing would work. And now we're going to talk about our second type, the convergent boundaries, and this is where those continental blocks are slamming into each other. So something's got to give when two things that large slam into each other, and we're going to talk about what the dynamics of that collision look like. So I mentioned this last time with the Pacific plate. We had it moving away from the Nazca plate last time. But over here on this side, what's going on? Because it's moving into the Asian plate. And so what's going on right here along this boundary is what we're going to talk about now with the interaction of the Pacific plate as it's ramming into the Asian plate. Now, important here is that the Pacific plate, so this out here is all ocean, right? So this is oceanic plate. It's dense compared to the continental plate of the Eurasian plate there. And so that density difference is what's going to matter here. So in this cross-section area here, so we're talking about, this would be our Pacific plate right here. So it's nice and dense, right? And then we have the yellow, we have the lighter continental plate over here. So what happens, we have this plate going down underneath this other plate. And so the continental plate is sitting here, and it gets drugged down a little bit as this subduction zone is forming here, and the oceanic plate goes down underneath and creates this ocean trench subduction zone. Subduction zone is something that you do need to know about. And here's our other diagram of the plates, simplified a bit. And so before we did Nazca and Pacific, and now we're going to talk about the Pacific versus Eurasian. And note that I have simplified here. I've left out what's going on with this chunk of the North American plate sticking down, this Philippine Sea plate, and I just want to keep this a simple model right now. It is much, much more complex when we try to figure out what's really going on. So we've got the Pacific plate moving west, and we've got, instead of moving in the opposite direction now and making room, the other plates are moving towards. So now we have a collision, and we have to deal with what's going on in those collisions. So when that collision happens, and I would note on this figure that this one's backwards. I started to flip it, but then I thought that the words would be opposite direction. I didn't want to do that. So just think about it. Now we're going in the opposite direction. So here's our lithosphere oceanic crust, and it's denser than, again, lithosphere, but continental crust version. Okay, so this is the denser plate right here, and it is sliding down and under, creating a subduction zone, sliding down and under this continental crust here. in a little more detail about what can be going on there. Again, very simplified, but you've got this is subducting downward right here. And as it gets really deep, so it's starting some fractional melting. Again, we'll talk about Bowen's reaction series and the igneous stuff, and so you only get part of it melting, the parts that melt easier than the other parts. And you get some sediment things happening, things being shearing and maybe sediment deformation and metamorphism from sediments directly into metamorphic rock, which is a cool process. But you get this partial melting and the rising fluids. So we can talk about this as water containing lots of minerals, or we can talk about it as magma blobs rising up through the crust and popping out as a volcano. Either way, these are really, really good zones for economic development. And so if you see that a lot of the world's copper and gold comes from Indonesia and the other islands in that area, that's because that's where this rising fractional melting is depositing a lot of the material that we can then mine for copper and other economic minerals in those island chains there. Okay, subduction zones are really important, but they're not the only way. Remember, for a subduction zone to form, you've got to have a density difference enough for one of the types of crust, one of the plates, to win over the other. With continental crust being less dense, it'll float over the top, and then that'll force that oceanic plate down. But you do have the situation where you have continental versus continental, and one is not significantly different than the other in terms of density. So you don't have a clear who goes down here. So in this case, we get a collisional system where you have an orogenic zone or a mountain orogeny where you get buildup at the collision zone and you get mountain building happening. Orogenic zones are where mountain building is going on. I like to make an analogy like we have vehicles in a collision. So consider that there was another vehicle colliding here with this one. And let's talk about what would happen, right? So where the actual collision occurs, right here. Think about bumpers between two cars, right? And you get breakage, which is analogous to faulting. You get some heat and shear zones. You get some extreme deformation events right at the impact. Then a little further from the impact, you get these really, really tight, folded up. The metal gets folded on itself and compacted, right? See where that would be? And then a little further away, like along the hood here, you still get a lot of folding, but it's not as tight a folding as that first bit. And then really, if you've ever done body work on a vehicle that's in a crash, even if you've replaced the hood and the fenders and straightened the frame and stuff, if you look really closely, a lot of times you'll find a slight deformation further back from the original most damaged areas. And so we see from continental collisions, we see analogies to all of these things. We'll see a massive shear zone right at the impact. We'll see a tight folding a little further away. And then we'll get into a more gentle folding area. And then eventually kind of a cryptic folding where it's really hard to tell that it even happened, but it's there if you look hard enough. So all of these zones will happen, and I'll come back to them when I talk about some of the places where these collisions are happening right now. So I've mentioned before how the Indian plate here, right? So you've got the Indian plate, and it's slamming into the Eurasian plate. And so you get, this is where I was talking about like the two cars just slamming into each other at the bumpers. You get this sheared up zone right there, and then you get this tight folding going on. Here, in the case of the Tibetan plateau, you've got some more complex stuff, but then later on you'll get that more gentle folding out there. We can see the same stuff happening if we look at the geography of Iran here. By the way, this is an image from the Johnson text, so if you've already read it, you can see there, or if you're going to read it, then you'll see it later. So you get this collision here happening, and lots of damage right there, and then you get really tight folded belts right there, and then as you get further out, you start to get less intense folding as you get towards the Gulf Basin here. We can also see this close to home. So this area down here is the Piedmont. So Piedmont is like where Atlanta is. This formed with a collision that created Pangaea in the first place, where we slammed into the African and Eurasian continents all at once. And so you get this zone down here that is so sheared, so beat up, metamorphosed. It's really complex mapping down there. I've done a lot of that, and it can be really hard to disentangle all the different things that happen. Just like that vehicle collision right there where the bumpers met each other. It's really messed up. Then you get some heat influence here where you get the faulting and the igneous stuff coming up in the middle. And then a little farther back, and here we're in the analogy of that first crumple zone that we talked about on the vehicle collision analogy, and you get these really tight folding and faulting going on. And then as you get further away, and now that's where you get to like Lookout Mountain and Pigeon Mountain, where you guys mapped in the topographic mapping exercises, you get this more gentle folding area. And then further away here, you would get, this is kind of like the Cumberland Plateau area. If you're going out into Tennessee and into Kentucky, you get, it's actually folded, and you get things like the Cincinnati Arch and stuff like that. But it's so far away now from the collision zone that the impacts are harder to see as a surface expression. They're still there, but you have to dig for them a lot more. Well, that's it for convergent boundaries. So next we'll turn to transform boundaries. And if you want to read ahead, that's section 2.5 in the Johnson text. And for the Lumen text, I guess it's still just mixed in their what they call readings for plate tectonic theory.